All right, chapter 5. We'll see how long my board holds up. So, chapter 5 is all about decisions. So, starting into how to make the computer allow it to make a decision or make a choice between one or more possible block statements or outcomes depending on if a condition is met. So, the if statement lets a program carry out different actions depending on a condition. So, if we were to think about our bank account from chapter 3, we had withdraw double some amount. Outran my board. Okay. And then we said, balance equals balance minus amount. And it updated our instance field. The only problem with this is if my amount exceeded my balance, so far we don't have any check for that. This is a very generous bank. It'll give you a loan right there and then. So, I mean, if, for instance, balance, if balance equals 400 and amount equals 500, then my balance all of a sudden is negative 100 and I have a problem. So I need to create some sort of a check for that. So the way an if statement works is, depending on how you set it up, if some statement, if it's false, you go out and do something. If it's true, you do something else. They can meet up. This would be how it will be designed for the balance. So if true that my balance is greater than my amount, go ahead and do the withdraw. If not, do nothing. So, and when you think about it, you can say if my amount is less than my balance, go ahead and withdraw it. Less than or equal to. Oops. Now this will only run if my condition, which is right here, let's call my condition. If my condition evaluates to true, then my block in this case will run. Okay? I don't need to put curly braces unless I'm doing an actual block statement that is more than one line. Be careful, an if statement will automatically run the first line without braces. But if I want to do more than one thing for a particular condition, I have to put it into it in curly braces to force it to run the entire thing. Okay. If I wanted to do something specifically if my condition is false, so we had some sort of like overdraft penalty or fee or something. All right, so an if else. If condition true, run this part. If false, if your condition evaluates to false, it will run the else. If I want to do more than one thing, like I said, so if condition, right, my curly braces, it'll run every line sequentially in that block if the if statement is true. Okay. So self-check questions. If I were to look at question number 2, what is logically wrong with the statement if amount is less than or equal to balance, new balance equals balance minus amount, balance equals new balance, how do you fix that? There's a double. Yeah, sorry. What's wrong with double? New balance equals balance minus amount, and then just stringing out balance equals new balance. What's wrong with that? Well, it's only going to run, because there's no curly braces, it's only going to run your first line. Then it will run your second line, so it will work properly, except that it will always run this line, even if your amount is less than, your balance is less than your amount, because it only runs the first line without a curly brace. So to fix it, you'd have to put it into a block statement, and then it will only run that whole section. One thing you do need to be careful of is to line up your braces. It makes things a lot easier to see and read. So for instance, I open one, I close one. I open one, I close one. I open one, I close. It makes it a lot easier to match them up if you indent. Plus, on the AP exam, if the indent here implies intent, okay? And intent was implied that those were supposed to be sequential and like stacked in like that. All right, if you write everything all in one line and you forget to put in your braces, then they're going to grade it like that. If, however, you indent and forget a brace, if you only forget a couple, your intent is implied and they'll actually let it go. So, relational operator compares how I test the relationship between two values. Remember, so this is 5, 2. Remember, the equal symbol, that's the assignment operator, which is not a conditional check, right? If I want to check if things are equal to each other, if they are primitive types, I use that. If they are objects, hopefully there's some sort of equals method that I can call. Otherwise, on page 188, you see your math notations and how to write them. Exclamation mark means not. Again, that warm-up 1, or actually really any of the coding back online assignments, but particularly the warm-up ones have a lot of if statements, so that would be great practice to go check those. One thing you do need to be careful when comparing values are comparing floating points or doubles. Because of the round-off error or the fact that, you know, if you go out to how it stores it, if you go out to 10 decimal places, it might be a little bit off. So we'll actually test if they're close enough. It's not something we're actually going to really do too much of, but you should know that that is how you're supposed to do it. So you can test the absolute value is relatively close to some very small threshold number. The threshold value in programming is considered to be epsilon and is usually set to 10 to the minus 14th when testing double numbers. Okay, so you need to check if two doubles are close enough to be considered equal, and that check is on page 198. So final double epsilon, it's actually already been set for you, but and you do get to use the one, like the E notation for scientific notation. And then we could check if the absolute value of x minus y greater than or equal to epsilon whatever we want to do, but essentially we'll write a comment x, you know, equals y under this condition. We would assume that they would be the same. Comparing strings, gotta be very careful. I can use the double equals thing, the equality operator, but that checks if the memory addresses are the same. So that checks if the things are the same string, not if they contain the same information. So we have two ways of doing it. You've got an equals ignore case, if you don't care about the case. So for instance, something like if string, you know, 1 dot equals ignore case, you know, string 2, it'll check, and then if that's true, it'll do something. If I do just dot equals, remember capitalization matters, so you often use this, if, for instance, to check if the user entered something like Y for yes or N for no. Well, you're just going to, instead of doing an equals if they did an uppercase letter and check if they did a lowercase letter, you say equal, ignore case, check them all at once. Okay, I can also compare, use the compare to method, which returns a value if they are in dictionary order. So I'll let you know which one alphabetically come first. The trick is that case sensitive, and source characters are putting numbers first, then uppercase letters, then lowercase characters. So Harry with all capitals compared to Harry lowercase does come out to be that Harry all capitals should be first. Now, page 191, comparing objects. Remember, if I use double equals, it only checks if they refer to the same object, which again, it's kind of bad programming to set up two objects to be the same thing. So if you look on page 191, I've got two boxes with the same name. Or sorry, I got two boxes and three names. Box 1 and box 2 all refer to, both refer to the first rectangle. Box 3 refers to the second one. So the comparison box 1 equals double equals box 2 is a true statement because they do in fact refer to the same one, whereas box 1 equals box 3 is false because they refer to different objects. Doesn't matter what they have inside. So really, if you want to see if the two objects are equal, you're generally trying to see if they contain the same information, which is a very different setup. Okay. All right, testing for null. It's a special value null if it refers to no object at all. Sometimes I can check for null. Usually, you check before you run something on it. You're going to throw an error if you try to run a method or something on a null object. So you would check if it's null. That's the one time on you would set double equals. So you would say something like, if I have some string middle initial and I was going to do something, I need to check if there's a middle initial there first before I can substring it to get the character, otherwise I'm going to throw an error. So I would say something like if middle initial equals the reserved word null, then I got to do something else because I don't actually have a middle initial. That's the only time you're going to use equals equals on an object. All right, going into 5.3, multiple alternatives. I can do multiple conditions combined to evaluate complex decisions. The correct arrangement depends on the logic of the problem to be solved, but it does make a big difference. So this is where, instead of doing if else, I'm going to do if, and then an else if another condition, else if another condition, else if another condition. So let's go ahead and look at that. Again, you should have written, especially before we go to class, the Richter scale tutorial, so the earthquake and earthquake runner, which start on page 193 for section 5.3. So let's open that up and go ahead and take a look at it. All right, so if we look at the editor for earthquake, public class earthquake, I have one instance field, private double Richter, and then my nice comments, Java duck. So this is my constructor. Constructs an earthquake object with a given magnitude provided by the user as a parameter. Then I just save that in my double instance field Richter. Then I'm going to return description. Okay, so public string, I'm returning a string type, get description. All right, so if my Richter value is greater than or equal to 8.0, I'm going to create the string R and say most structures fall. And then notice here at the very, very end, the last thing I do is return R. Now, in this case, have 1, 2, 3, 4, 5, 6, 7 choices, right? So my next choice is if the Richter is greater than or equal to 7, then I set my string R to many buildings are destroyed, etc. Now notice, you wonder, well, why if I have a Richter of 8, it will not trigger the many buildings destroyed. If my Richter is 8, it will trigger most structures fall because of the order. It does test an if statement in order from top to bottom. And when one fails, it instantly goes to the next one. So if, let's say, my Richter value was 8, then this evaluates to true, and it runs this part, and then it kicks out of the entire if statement. So it will never run the next part. So it only gets to this statement if it fails the first one. So if my value for Richter is 7.9, then the test for greater than or equal to 8 fails, It then tests 7.9 against the next condition, which is greater than or equal to 7. That evaluates to true. So my string R is then set to many buildings destroyed. Since my condition evaluated to true, I kick out and I just go down out of the else, which ends here at the end with an else statement. And then I do my statement return R, which is outside of the if condition. And then I'm good. I go from there. So in the earthquake runner, I create a scanner object. All right. And then I print enter a quake magnitude on the Richter scale. I save it by using in.nextDouble. I save my magnitude. I create an earthquake object of the earthquake class and pass it my magnitude that the user entered. And then I just call the getDescription method. So let's run it. So enter a magnitude. 7. Many buildings destroyed. Okay. Now, when you're testing it, you should test that everything works. Okay. So for instance, my last check is if I'm greater than or equal to 0. All right, and it's called generally not felt by people. So that's actually a fairly big split. That's anything less than 3.5 and greater than 0. And then my default case is if I haven't hit condition where it's greater than or equal to 0, it has to have been a negative number, and it should say, not valid. So this is my boundary cases. I should check the top one. If I put in 75, it should say most structures fall. If I say 0, and you want to test like each of these, right? Because if I put in greater than or equal to, right? So I want to see if that works. So I should put in 8 exactly, and 8.5. All right, I should put in 0 and see if it says something, and then I should also put in a negative value and see if that works as well. Now, if you look at page 195, the order of this is very important. So you have to sort the conditions and test against the largest cutoff first. If we went in the wrong order and started out with Richter greater than or equal to 0, it will, unless I put in a negative, it will always spit out the first part because that'll always be true and it will never make it to the rest. Remember, it only sequences through a series of if conditions until it hits one that's true, and then it's done. So if the first one's true, it never makes it. Okay. You also want to use an if-else else to test, not just multiple independent statements, because those are independent and they're not sort of tied together. So if I have if Richter is greater than or equal to 8, most structures fall. If Richter is greater than or equal to 7, many buildings destroyed. If Richter is greater than or equal to 6, many buildings considerably damaged. If I put in 8, then the first if evaluates true and it says most structures fall. Then it will say if Richter is greater than or equal to 7, which is also true if Richter is 8, then it will reset R to many buildings destroyed. And it'll actually go all the way down and then trigger, and the one it will actually return is generally not felt by people. All right, because each if statement, you only get one if to start your conditions. They're all independent. So if I want to have multiple alternatives, they have to be an if and then else if and else statements. All right, I'm going to jump ahead to page 198, nested branches. So some computations have multiple levels of decision making. I can put an if and then have an independent if statement inside of it if I need to do something like that. So for instance, if I was going to have a tax bracket, if you look on page 199, my first condition is, are you single? If it's true, you have 2 different choices for your income, which then turn into 3 different tax brackets. If it's false that you're single, that is you're married, you again have 2 different tax brackets that turn 2 different conditions for your money income that then turn into 3 different tax brackets. Okay, but in this case, the left side of the page, my income less than or equal to $21,450, put me into the 15% tax bracket, will not trigger, or should not trigger, if the first one triggers false. If my first condition, are you single, triggers false, it should go over to the right side, and thus it will never run. So let's go ahead and open up that one. And let's take a look at that. So, tax return. Got a couple finals here, which equate to different conditions. And it's easier to use numbers instead of the strings. You'll see why. And then my tax rates. and my two instance fields, income and status. Then I create a tax return object with an income value and a status, the status being single or married. Alright, then I call my getTax method, which actually returns the amount of tax that I would owe. So my tax 1, tax 2 start at 0. If status equals single, alright, single being a constant labeled as 1. So if I enter 1 for my status. So that's my first condition. Alright, so if status equals single, that is status equals 1, I run this block. Alright, which also then contains the two different rate cutoffs to determine my tax bracket. Else, that is to say that my if statement failed. I only have two options, so I'm not going to do an else if. I only have two options. I'm either single or married, so if I'm not single and that triggered evaluated to false, it will run the else portion with my two new numbers for my income. All right, and this one's a little bit different. This one's a version that's got a few different changes in it, but the idea is the same. I got nested if statements, and so we could go ahead and check the calculator tester. So make a new scanner, enter your income. Are you married? Yes or no. Okay, now here I actually, because these are static constants of the tax return class, I can use them elsewhere. They have to be static if I wanted to use them out here in the main program with no objects. So I haven't even made a tax return yet until this line down here. However, I can say if my input equals ignore case y for yes, that you are married, then I instantly set my status to my tax return.married field, which equates to 2. Otherwise, if it entered anything else, essentially, then yes, I have to be no. So I set my status to single. Then I create an object of the tax return class, passing it my income and my status parameters, and then I print out my tax result. Let's make a new one. Enter your income. I am a high school teacher. $10,000. Are you married? Yes. I owe 10% of my income in tax. Okay. Now notice there is one potential problem. Okay. As it's written out, please enter your income. 10,000, comma, like that. Are you married? No. Oh, that seemed to work. Alright, it did seem to understand the syntax in which I wrote it and didn't pitch a fit with the comma. So that was good. So that's multiple alternatives, and I can nest if statements to make different outcomes. Now, one big problem, and I can guarantee you that there'll be samples on tests and quizzes that outline this, what's called on page 202 the dangling else problem. Okay, so when an if statement is nested inside of another if statement, the following error may occur. If Richter is greater than or equal to 0, if Richter is less than or equal to 4. The problem is that the indentation level seems to suggest that the else is grouped with the outside test Richter is greater than or equal to 0. It is not the case. The compiler doesn't care about your indentation and follows the rule that an else always belongs to the closest if statement. So you would then say if Richter is greater than or equal to 0, and if Richter is less than or equal to 4, print the earthquake is harmless, else print negative values not allowed. Which means that if my Richter value were to be, say, 4.5, it will print negative values not allowed, because it will tag the else to the closest if. So what I would need to do is put that second if inside of a series of braces to force the compiler to tag the if and the else as we expect outside. Alright, so it's always good to have a set of braces, especially when the body contains another if, so to force you to do it. So that's your dangling else problem. Okay, so that would be, so the thing to remember is that an if statement and any else command, unless forced to evaluate to a specific if using braces, will always evaluate to the, or tag itself to the closest one, which is rarely what you actually meant it to do. Alright, that ends 5, 1 through 5, 3.